Okay, I'm going to see if that thing records better than the other suckerific thing I've been using. It keeps dying on me. Okay, so double replacement. Now, not all going to be double replacements, but this one's double replacement. Aluminum and sodium, those cheating dogs, are going to switch. And sodium's going to run off of nitrate. And we know that that's going to happen. Is that sodium is going to be a 1 plus and nitrate a 1 minus. Okay? So hopefully tomorrow you've got your polyatomics down. You won't have to know all the solubility rules tomorrow, but you should have your polyatomics down. And aluminum is going to run off with hydroxide. Aluminum is a 3 plus, hydroxide is a 1 minus. Okay? And so you got this guy. Alright, now, what were the rules for nitrate? Nitrate had a special rule all its own. What? Nitrate never what? It never forms anything that's solid. It's always aqueous. Okay? Hydroxide is aqueous unless it's with the ammonium and the alkali. And then the really heavy alkaline. Okay? But over here, what's going to happen to sodium nitrate? Nitrate is still soluble, so aqueous. And then this bad mamma jamba is a solid. Okay? To balance it, this should be a 3 and this should be a 3. Why? Because you want to look at the whole nitrate. There's 3 nitrates. So we have 3 nitrates, which gives me 3 sodium, ergo 3 sodium, 3 hydroxide, 3 hydroxide. Okay? The only mistake I saw was that somebody had accidentally put a charge in. You would not do this, because at the end, those are canceled out. It's become charge neutral. Otherwise, it would keep tracking things until it was. Okay? Now, if we want to make this into a net ionic, we break up the things that are aqueous. So the aluminum is gone, because it was aqueous. The nitrates are now broken up, because they're aqueous. The sodium is broken up, and the hydroxide is broken up. On this side, the sodium and the nitrate are still broken up, but who's together forever? The aluminum hydroxide, the alum, right? Yes, hi. Do I not have a 3 somewhere? Oh, thank you.
So how do you know if things are together or broken up?
So the only way to know is by memorizing the solubility rules.
Oh wait, now I remember. But we won't have
You don't need the solubility rules memorized by tomorrow. No, you should be able to set. Go ahead.
No, so for the final things we have to have like that separated.
The question today was this guy here. This was all you need for the question today. We're getting there. So if I'm going to give you the solubility rules tomorrow and have you use them, but you don't have to have them memorized. But I do expect that you have your polyatomics down by tomorrow, okay? But not the solubility rules. The next quiz maybe, but not this one. All right, sorry, I lost my train of thought. What were we talking about? Oh, we were going to end it. Okay, so net ion. All right, so now, what things are the same on both sides? Sodium and nitrate. So these are spectators. They're watching. So what are you left with? The aluminum sees the hydroxides. Oh, hubba hubba. And it becomes aluminum hydroxide. Remember we said that when you write out a net ionic, it's not necessarily to always put down the phases because it's implied. If it's a 3 plus, it's because it's in solution. It's a 1 minus in solution, and if it's not, it must have precipitated. And so at the end, that's the precipitate you would see. Okay? Okay? Is that your net ionic? So we're just going to practice a bunch of these today. Just a bunch of net ionics. Okay? Sound good? All right. So let me see here. We did an acid one. Let's do this wonky guy. I'm just going to turn this off completely. This is going to get harder every year as I keep shrinking. So I keep hearing people complaining about all the hormones in our food, but I feel kind of like jealous because if I were, a kid now, I'd be probably a lot taller if I had all those hormones in my food. My dad was like 6'2". Yeah, I know. And look at me, such a crap. Wish I could have had some of those hormones in food. Tall people. Okay, so we got these two guys here. All right, what are the rules for copper? We don't know. Uh-oh. So if we don't know the rules for copper, we're going to default to it's probably going to be soluble, unless it's one of the things that we have another established rule for. And we do have something for nitrate. We know all of nitrate and all of acetate are always soluble. So this bad Jackson is aqueous. And ammonium, if you haven't caught on yet, every time ammonium is listed, it's listed as being something that dissolves, right? If you haven't caught that yet, ammonium is one of those important things that nothing wants to solidify with. But the rule we do know is for sulfur. And the rule says that sulfur tends to want to be insoluble, except for what? With ammonium, alkalis, okay, and a few other things. So we're going to make this guy aqueous. If I can write it down. All right. Again, it's a double replacement. What's the charge on copper right now? So this is copper 1 nitrate. One of the things I saw in the labs that you guys made mistakes on is you accidentally use monodi-tri where you shouldn't have. So this is going to be copper 1 nitrate, and this is going to be ammonium sulfide. Okay? And they're going to double replace. Copper and ammonium are going to switch dance partners. And so copper is going to still be a 1 plus. It was a 1 plus here, it'll be a 1 plus here. We're going to see a thing called redox where they change, but this is not it. Today is not that day. Yes, sir?
So why would, because aren't you switching copper with sulfur?
Copper with ammonium.
Oh, okay.
Copper's going to switch with ammonium. The men are going to trade partners. They can't be trusted. So copper's now going to run off with sulfur. But wait, copper was a 1 plus. What is sulfur always?
2.
So this is going to be still copper 1. The 2 drops down. The 1 drops down. Okay? What's the rules for sulfur? Go ahead and look at your rules for sulfur. Sulfur likes to be when? Ammonium? Alkalis or any other things for sulfur? And that's it, right? So what's this going to end up being? Solid. Okay? And now ammonium nitrate are going to run off in leftover bliss and be aqueous. The two least solidifying things off of the periodic table. Okay? Now we could write out the complete molecular equation. We could. But hopefully you're starting to see at this point, if something is an aqueous on the left and aqueous on the right, it's going to disappear, right? So, can you look here and see any things that we're going to neutralize right away, disappear, go away? Yeah, the NH4 is going to be gone, and the NO3. We can see that this guy on this side had an aqueousness and a pump. And this guy had an aqueousness and a pump. So, they didn't change, right? But copper was aqueous and sulfur was aqueous, and now it's a solid. So we can now shorten this up, save ourselves a step. Well, let's take a look. How many coppers are on the left? How many are on the right? 2? 2? Oh.
Yeah, that's what I'm saying.
Okay, now we look good?
Yeah.
How many coppers are on the left? How many are on the right?
2.
Okay. How many sulfurs on the left?
1.
How many on the right?
1.
Okay, are we done?
Yeah.
Okay. So, when you asked if we had to balance it, what I thought you were going to say is, hang on, I thought you were going to tell me that you wanted me to do this, and that you wanted me to do this. However, there's a reason why I wasn't going to futz with that. Okay? If this is the final answer, then we're going to end up deleting half that stuff anyway. So, one of the nice things is as you get faster at these, you can start just skipping straight down to the second part. Yes, ma'am?
I thought copper was just the 1 plus.
It is.
Oh,
And so, I'm a jerk. Thank you. That's it, yeah. Don't worry, I'll screw up about another 5,000 times today. Okay? Keep me honest. So far, so good? Yes, sir?
Yeah, why would copper be a 1 plus if it's a 2 plus scenario?
So copper is one of those weird things that can be a 1 or a 2. It depends on what it's with. In some cases, copper will be a 1, sometimes it'll be a 2. What we're going to find later is its ability to pull electrons away from the other object kind of dictates how far it's going to go in its charge. With things that are very electronegative or not, and so forth and so on, we'll get to that, but that's a very long conversation for a different day, because we have to look at the size of the ion, what it's with, and then we have to look at the electronegativity and the electron configuration. There's a bunch of considerations that go into that.
Unless it's labeled, I can assume it's...
So we're just telling you it was copper 1, so it's going to stay copper 1. Okay, then just leave it alone. When we get to redox, we'll start to get into that. Okay? Other things. Anything on all things? Some of the things? One of the things? Okay. Want to do another one? Yes, I do. Okay, good. All right. Good. Okay, this was a little harder. Only marginally. Only marginally. Okay? Only marginally. Okay. So I'm going to set this one up in 2 different ways so you can see the nuanced difference. Okay. You have acetic acid, and we're going to pretend it's pure acetic acid. Okay? Acetic acid is a weak acid, so it doesn't fully dissociate. Okay? Over there, it's a liquid. You'll see there's two different ways to write this out, and it depends on kind of some of the nuance. So sodium is going to run off with acetate. And sodium acetate, we know all acetates are aqueous, and everything with alkalis are aqueous, so this guy's definitely aqueous. And you're going to be left with, what's H and OH?
H2O.
Yeah, water. Okay? So, we could write this in a couple of ways. You might be tempted, don't write down what I'm about to write down. You might be tempted to do this, and do this. Because you have a water form at the end, hydrogen and a hydroxide. And so you can see that these guys change into water. You might be tempted to do that. Don't do that, okay? Here's why. When you have something that begins as a liquid is not the same thing as aqueous. Liquid is not the same thing as aqueous. So if it's specified that your substance, this weak acid, is a liquid, let's say, again, that's not the same thing as aqueous. A liquid is this molecular substance, and now it's becoming something aqueous. And so we can write this down, but this guy did change. But what did? Sodium was aqueous here, and sodium was aqueous there. Okay? So this guy did change. And so what this would look like is a little bit, and it's just a tiny bit different. Okay? Because it was a liquid at the beginning, it was a molecular substance at the beginning, what we can think of it as you're creating water, and now some free acetate. Do you see the slight difference there? What a net ionic does is it writes down whatever has actually changed phase or form. Okay? So if something was liquid before, now it's aqueous. Those, I know that sounds the same, but aqueous specifically means broken up into ions in water, conducting electricity. Now, do you remember when we got the vinegar out and I put the electrodes in it? Did it bright up? A lot? Or just a tiny bit? Just a tiny bit. And that was vinegar that was in water. That wasn't even pure vinegar. Okay? So that had some water to help it dissociate. So pure vinegar is a pretty piss-poor conductor, part of my language. But it is. It's not a very good conductor. Yes, sir?
So, because I thought we were only supposed to break down the aqueous ones.
Right. We didn't, and so we didn't break that down. Okay?
That still comes down with the net ion.
Because we didn't break it down, it changed form at the end. It's part of the net. The net ionic shows you what actually changed form and phase. What really did change. And in this, the sodium never changed. The sodium was just a spectator, be like, yeah, this is exciting, but it doesn't do anything. The hydroxide, though, bonded and became water. Hydroxide, picture a hydroxide. Okay, it's a viscous, slimy substance when it gets wet. And it's remember, you guys ever got hydroxide in your fingers when we did some of the labs? It feels slimy. No? Viscous was really well, a little bit slimy. And it burns flesh off your bone. It slowly will, like, okay, so you know in the wintertime when your hands get all dried out and cracky and bloody?
Yeah.
That's what hydroxide does. It will do the same kind of thing. So it starts to slowly dissolve skin. Okay?
Cool.
Water. If you get water in your hands, do you think yourself, no! My hands are burning! Right? No one wicked witches. You're fine. So we went from something that was vinegar, so acetic acid, has a smell like old man feet, okay? And a substance that is good at dissolving skin, flesh, you know, with Drano. You pour it down the drain to break up hair clogs and grossness. This is good at destroying organic matter. And we're left with water and acetate. Acetate is just an ion in solution. And so now, this would have gone to make something that would be a pretty good conductor at the end still, because the acetate, it was a good conductor because of the hydroxide, and a good conductor at the end because it's free acetate, the sodium acetate. Okay, but the acetic acid itself changed. It went from being a liquid to now aqueous. Liquid and aqueous are not the same. Liquid and aqueous are not the same. If you remember, we put the light bulb in it, and it barely conducted at all. But now if we put a light bulb in that end solution, it would brighten up. And you'd be like, oh, this is amazing! And you'd be all excited because your light bulb would brighten. Okay? Excuse me, so they are different. Okay? That's what I mean by slightly harder. You just have to remember, excuse me, if it starts off as a molecule and ends as aqueous, that's a change. And then that ionic shows the change. Feel okay still? Not terrible? All right, let's do, let me choke to death. Let's do, let's do one more together. And I might have you try some on your lonesome. I breathed in Coca-Cola Classic. Things you shouldn't do. Try to talk and drink and breathe at the same time. All right. Science. What do we want it to be with? Sodium? Yeah. Okay. So we have strontium chloride, not strontium 2 chloride, because strontium is not a Roman numeral guy. And we got sodium sulfate. So strontium chloride and sodium sulfate. Okay, try and see if you can finish this guy out and net it out. Try and build this guy. Let's pause this for a minute.